To round this up, because I'm guessing you probably have most of this stuff at home. You need a small plastic bowl or container of some kind. This is literally just like from my kitchen. I brought these in, like one of those like little reusable things that you could store leftovers or something in. Anyway, so like a small plastic bowl, and then you need a bigger plastic or a bigger bowl or container. This is like a drawer to one of my totes, but something that you can put water in and fill up. Because plastic is going to float, but I want to know how heavy I have to make this to sink.
If you put Orbeez,
and does a bigger container require more or less water or weight to sink it? Why? So we're going to be testing these things. So that's what you're going to need. And then to weigh it down, I've got my bag of pennies back. So you could use any kind of a change that you have at home. Like if your parents have any spare change or you have any change in like a piggy bank or anything. Something that can fit inside the little cup that you have. If you're not going to round up these things, then I can turn a camera on one of the groups that's close by. But give me a second. I am going to pass out these things. I need, and you are working with table partners today. Jason, you need to select one of the groups that has 3 people at it. Because we are dealing with water today, I would like all the Chromebooks on the floor, off to the side in a chair, an empty chair at your table, somewhere out of the way, so that they don't get wet accidentally.
My Chromebook is safe.
Okay, Macy, you too. Chromebook has to go away, everybody. Make sure that they're not somewhere that you might accidentally step on them. Yes, if you could give everybody one of these.
Everybody.
For every table, sorry. You're gonna pass out.
It looks like dead rabbit. Hey, what is inside of that container? Seriously, what is it? Cereal. What is that?
What is this?
What is that?
It's a bowl.
Yeah, but inside of the bowl.
It's stained.
It's just stained and old. I have literally had that bowl for like a long time. I'm going to start filling these with water, and then you can pass them to the table.
No, what if you had to? What if you had to drink it? What if it's been 7 and 11 years since somebody has drank it?
That'd be like 2.
And what if it was, wait, actually, no, we're Sean, I got a better version. We're Sean. Sean.
What I said?
Sean, no, seriously, Sean, listen. Guys, listen.
It's okay. I like the
Sean, what if somebody eats 8 out of it very often, but glasses. Okay. What?
What?
I have a better one.
Don't stick your head in it. Is it cold water? Yes. Thank you. Can I have one just for me? Hey, get the better No, he ain't. I'm a mess.
Oh my god!
You want drink?
Their plate is beautiful.
Alright, guys, you don't need to do anything yet. Just anything in the water yet. Class. Do not put anything in your water yet. Please stop. If I were you, I would place your water bucket, if you have a water bucket, in the middle of your table.
Do not trust Jason with that water.
Okay, guys.
All right. I literally said don't put anything in the water, and I see multiple groups poking things in the water. All right.
No, so it's still until everybody's back.
Before thank you, Fiona. Thank you. All right. We are all set up. I apologize. I wanted to have this set up but ahead of time, but we had recess and I had duty, so I could not be in here getting this set up ahead of time for you guys. Now, before we get started on anything, I want to ask a question.
I might have an answer.
How much weight do you think we can add before
How much?
a container, a boat would sink? Okay, now, first I will say and give you some.
Jason put the bowl in the water. He put that bowl in the water too.
That one can't get wet ahead of time because it's not waterproof. And that will affect it. I have an extra one. Jason, you can sit at your desk and watch the experiment because I said multiple times not to put anything in the water. So, well, here's the deal. Keep everything on that side. I will give you guys another paper bowl. You are not allowed to touch anything at this point.
We got a new one.
Okay. You are not allowed to touch anything. You are just watching. You can come sit at the table, but you are not allowed to touch the experiment stuff. You are just watching. All right. Now, research. Don't confuse research with data. Okay? You guys are going to want to confuse data and research. So research is something that happens before the experiment begins. It is information about our topic. So first off, we need to know what kinds of things float and why. So why does a rock sink in water, but maybe a giant steel aircraft, if it were to just float there, why would that float?
It's hollow.
Why can we float, but a rock sinks?
We're kind of hollow.
We're kind of hollow?
We have air in our mouth.
We have what?
Air.
Air inside of us?
And breathing. When there's air.
And why does air
Because it's
not sink?
Because it's light. It's basically nothing.
It weighs less than,
It's like nothing.
dense than water.
okay,
I did this kind of experiment when I was in a pool.
okay.
We did this with foil.
So things, it doesn't matter, Greg.
So basically, I'm thinking maybe we can measure the Tupperware in the cubic feet and the little bowl.
Okay, and that will be, that's actually going to be part of our data.
Okay.
So, all right. So the weight of an object isn't always necessarily what makes it more or less likely to float. Do you want to be cut out of the experiment as well?
No.
If you guys don't stop sticking stuff in the water, you will go in the hall. I'm that close to saying just don't even be a part of it at all. Stop and just wait and listen. You're driving me nuts. Some of you are just being flat out rude. Enough. Okay, so we're going to figure out how water and gravity work together to either keep something afloat or sink it, okay? Because gravity still exists even in the water.
Because the water is going.
And if I were to just hold this in the air, I can't, it's not going to float, right? It's not levitating like the car in last week's experiment. It's dropping. Gravity's still here. But if I were to just sit it on top of water, right? We know it's going to sit there, right? So, but gravity's still underneath the water. Why is it just pulling straight down?
Because it has air.
Miss Beth, I have another thing. If you turn the bowl like this and let it, I think it would sink. Because then it
Because
would.
the water is going up.
But maybe it wouldn't. Because maybe the water can trap the air in it. And
Oh yeah, wait. I actually learned this. Water can't go up into something. Water can't go up into something. Like you can put a bowl underwater and there's like a little tiny thing of air under the water.
I mean, all right, Josie, go. I love this discussion.
Gravity won't put down because of the water pressure.
Water pressure, all right? So there's a word I'm going to throw at you, and it's really hard to spell, and I literally keep having to look at my paper every time I say it to figure it out because it is like not a word that makes any sense to me for as far as spelling, and it is called buoyancy.
Oh my
And
God.
buoyancy is how well something floats.
In water.
So that's part of our research. We are going to look up the definition of buoyancy. Hang on.
It's blocked by securely.
It is not blocked by securely.
Because you're the teacher, you get to do whatever you want.
It's just thinking. Buoyancy, the ability or tendency to float in water, air, or other fluids. All right. The ability to float. What causes buoyancy?
Happiness.
Air.
Buoyancy forces point upwards because the pressure of water is heavier the deeper you go. So remember back when we talked about the hydrosphere and we talked about the deeper you go, there's less life and it gets darker and you could actually even get crushed. Our bodies are not capable of going.
Some submarines can get crushed in there.
Right. Our bodies cannot go to the very, very bottom of the ocean. If you went out to the middle of the ocean where it's the deepest and went down, our bodies alone, just in a little scuba suit, could not go that deep because the weight of all of the water above you pushing down is too great. It would literally crush you. Kane.
I actually know a lot about like all of this stuff you're talking about because my dad's a diver and I'm thinking of becoming a diver.
What? This is all new information. Your dad's a diver?
Yeah, he's a certified diver.
I did not know this. This is new information and this is exciting. Okay, very interesting. So Kane already knows all about this. Now, so because it's more and more water pressure, the deeper it goes, things are likely to sink to a certain point, but it gets actually harder to sink the further they go down. It causes more weight. Now, B, you had your hand raised. Yes, no?
But what I was going to say is that I went to a deep swimming pool one time. It was my aunt's house, and she took me to grandma's house, and we went there, and she has a 20-foot
Macy, take that off your head. I can't see around you.
20-foot it's like it gets deeper.
Uh-huh.
It starts off at like 2 feet deep, and it gets 20 feet deep. And I went all the way down to the 20 feet bottom of it, and I could just feel the water pressure.
Right, yeah, if you go in a deeper pool, like you can feel the weight of the water getting heavier the deeper you go. Think about this, if you've ever been in a pool, you've got like a little floaty, maybe you've got like a little tube or whatever that you're floating around in. You can push the tube maybe barely under the water, but can you push it all the way down to the bottom? It's fighting you to come back up, right?
It'll go.
Yeah, and if you do get it down deep, it pops up really quickly.
It has air.
So all of that, listen, that water pressure that's down deep is pushing everything to where it's lower pressure, which is up. So the buoyant force of water, the water pressure is pushing things up, but gravity is pulling down. So it's this battle between the water pressure pushing up and gravity pushing down. So that's what actually causes buoyancy or things
Right,
to
it's
have a
because it equals
tendency
out.
to
Equals out,
float.
and then you can just pretty much float depending on. your
Yes.
weight.
So where you reach that point of the water pressure pushing up on you is equal to gravity pulling down on you, that's the point at which you would float. And that is where it's based somewhat on weight and also what the things are made of. Some things are more likely to float than others. And it's largely based on how much, sometimes like if you think about, like you said, the ocean liner, the plane, they have things that like full of air. Air is really hard, and like inner tubes or whatever in the water, they're full of air. Air does not want to go down underwater, doesn't mix, it won't stay. So it has to be pushed up. Our bodies, if you think, if you jump in the deep end of a pool, you automatically start once you get down, you are going to start rising back up. Even if you don't do anything, you will start rising back up.
If you have like a weight belt,
if you have a weight belt, it would hold you down. But think about this, if you throw something in the water, it's going to pop back up unless it is like a rock or something that's very, very dense and doesn't have any air in it whatsoever. So, but our bowl right now,
has air in it.
We can't see it because it's invisible.
Yeah, but see,
but it's full of air. Invisible little air, it's all in there. So you guys are going to be filling out our 6 steps of scientific method as we go through this. I don't have a worksheet printed out. Everybody's going to do it on Seesaw after we do the experiment, or we're going to talk about it. Maybe we'll just talk about it. So research, we learned about water pressure pushing up and gravity pulling down, and that's what causes buoyancy.
Just like the Earth holds in place in the solar system, the sun is pulling it in and the Earth is pulling it out.
Right. So Zeke said it's very similar to the balance of how our planet stays in that path and that orbit around the sun. The sun is pulling us in.
And the Earth is trying to.
But so, what was that called? Inertia, the tendency of an object to move in a straight line. Earth automatically wants to go in a straight line away from the sun, but the sun's gravity is constantly pulling us back in. Remember that?
It's an oval because the
It's
Earth
slightly.
is go straight.
Okay.
And when it gets to a certain point, the sun.
Now, so everybody, before we need to do this, we're going to think about our experiment, and some things are going to stay the same. At everybody's table, what is the same?
The amount of the same bowl.
No.
Okay, hang on.
Water.
We all have a tub of water.
Not the same amount.
And
Ours is 2
now,
and
here's the deal.
cubic feet.
Hang on, let me bring you guys over. Lucas and Cam, by chance, are either of you playing along, or are you just watching?
3.
Listen, I need to hear them. Lucas is watching, all right. Hang on, I'll pin you guys, so. All right, hang on.
Why is this a rock? Maybe I can make it blue.
All right, you guys are they're both just watching, so you guys
Wait,
are
is
on
this
show right now. All right, stop, guys. Why are we all talking? Huh?
There's 288 cubic inches in this bowl. I did the math.
Okay, so we reviewed earlier during math how to find volume, and that's actually going to be really important today. So some of our experiment is going to require us to collect some data, and I am going to kind of gather for us our, why are we talking? I'm going to try and gather some data up here for us. Lucas and Cam, I will present it to you here in just a second. Okay, so controlled variables, what's going to stay the same no matter what table we're at? What is staying the same? Raise your hands.
This time, I think ours is leaking something. It's like there's like water all over it.
Same.
On their table.
Okay, so that's not a watertight container.
Yeah, there's water. Oh yeah. Oh no.
I mean, I can
see it on your finger.
Oh, okay.
That bus.
And I can see you.
Okay, hang on. Bring me back one of them. And take that one.
I got enough.
We need new containers.
Bring me back the other one.
Here, I'll take it from the. I hope I don't. Want to be part of our new table? Please.
Guys, enough? All right, I'm waiting to hear control variables. I can multitask. What is going to stay the same at every single table?
The water.
No.
The table.
All right,
The table.
okay, I still have too many people talking.
What?
Josie, what? Give me a control variable, something that's not going to change. Not that one. Okay, put it in the sink because it's getting all over the counter. Oh, the kind of water. Yeah, salt water would have a different buoyancy than regular water. Okay. So type of water is the same. This pit is trash. What else is a control variable? Another control variable. Josie Moore. Now stay with me though. That's not going to be a control variable.
I don't think it's gonna. I don't know. I think it's gonna. It will. Well, I was just gonna say.
All right, girls, try that. You don't see a hole in it. Try this one instead. All right. That we all have a container of water. Yeah, Parker. What else?
The amount of weight that's going to be in because we're all using the same bowl.
We're okay. Same bowls.
No. Not the same bowl.
Hang on. Calm down. We all do have the exact same bowls. We all have a plastic bowl that is the exact same size. We all have a paper. We all have a paper bowl that is the exact same size. Okay? All right, so same bowls. We all have a bucket of water. Okay?
But their bowl
Now.
is different than
Hang
our
on. All right. You're not even supposed to be touching anything. Put it down. Down. All right. So what we need to do, these same bowls, we need to gather some data. So you need to measure, and we're going to find volume. Every table should have a ruler. Hi, I'm talking. And we're going to measure width at the top. You guys see what I'm doing here? Width at the top. But guess what? It's wider at the top than the bottom, isn't it? So then I'm also going to turn it over and I'm going to measure width at the bottom. And then I'm going to measure its height. Those three measurements. And write it down somewhere at your table. Okay?
Aim for the measure.
This is the data that we are gathering. Width at the
I don't have a
top.
good pencil. You guys are going to have to write it
All right, you guys are going to have to do something. Kim and Lucas are watching you, and you four are all just seeing this.
Here.
All right, so data.
Okay.
All right, plastic bowl. Width. Top.
Shouldn't all the things be the same? We measure.
Bottom.
Yeah.
And height.
Okay.
I am making a chart.
Oh, didn't mean to. Oh, good job, Miss Beth. Good job.
All right, I'm going to bring my board over on this side, so if I want to turn the camera around, they can see it too. All right, so I don't know if you saw them, but let me turn you around. All right, so I know it's hard for you guys to see. Let me see if I can get a little closer.
What are you doing?
Yuck, what did I just get on my hands?
What was it?
I don't know, something sticky that somebody dumped in my trash can up here.
Probably slime.
No, it's like liquid sticky.
Yeah, probably liquid slime. Yeah, like Macy's slime.
No, it looks like juice.
I don't have it with me. Ew.
Okay.
Oh, no.
So I've got plastic bowl. How wide is it at the top? They should all be about the same.
24 cubic inches.
What'd you get?
24 inches is 2 rulers long. It's not that.
No.
Is it maybe 24 centimeters? How wide is it across the top? 4 inches. I like that number much better. All right, 4 inches. How wide is it across the bottom, DJ?
3 inches.
3 inches. And how tall is my little plastic bowl?
2 inches.
2 inches. All right, so what is the total volume? 4 times 3 times 2.
24.
I'm just going to put a V for volume down here.
That's what I was.
Total volume, 4 times 3 is 12 times 2, 24, and it would be cubic inches.
Yeah,
Good.
I was saying the answer at first.
Okay, I was confused. All right, now let's measure our paper bowl. Okay, same thing. Width across the top, girls, make sure you come Riley. Width across the top, width across the bottom, and your height.
So what is it? 3.5.
Tony, do it up here so everybody can see.
Let's see.
Do what?
Really, Sean.
For this one, this is going to get us close enough.
You count. Enough. 1, 2. I can't
As
count.
long as we're using the same measurements for both bowls, we'll be comparing the same thing.
Okay.
That's going to get us close. Volume for a circle object is a little different than for a cube object,
Yeah,
but we're
do
going
the
to use
camera.
this because it's what we know. Okay? It's going to get us close.
1, 2, 3, 4, 5, 10, 12, 15, 16, 17, 18, 19, 20, 21,
5
22,
inches.
23, 24, 25, 31, 32.
5 inches and 12 centimeters. Done.
All right, guys, just another few seconds,
5
and then I'm
inches.
going to ask for some measurements.
Okay.
Hear that?
5 inches. Stop. Sean, stop.
How do you multiply?
That's 6. I found 6.
Okay, it's 6 inches, right, Kane?
I did it. It's 5 inches.
It's 6 inches. It's 6 inches.
It's 6 inches, guys.
See, look.
Okay, now can we move on to the next
6.
one? Next one, bottom.
Bottom.
Kicking me.
And like right here.
4.
4 inches. Can you guys see?
Height.
Height. So like this here. This game? So
Yeah, like that. Okay.
it's about 2.
It's about 2.
Okay. Oh, but I don't know if they can see. Can you guys see? It's about 2. Okay, we've got it all worked out, Sean. You already got it all worked
It's
out.
24
All right, guys, give me your width across the top of the paper bowl.
5 inches.
It's 6.
6
It's 6 inches.
Whoa, whoa, whoa. What do you guys vote?
6 and
6.
6.
5.5. Yeah, 5.5.
I can sit down. I already talked to your table. You cannot scream your answer every time I point to a different table. Stop. Okay. Now I don't even remember because you're screaming the same answer over and over again. Kane, what did your table have?
6.
5.5. 6.
What did you guys' table have?
6.
We're going to go with 6 because that's what most of us had, and it's an easy number to multiply. And it's pretty close. It wasn't exactly 6. Because if you measured from the outside of the bowl edges where it folded over, it was definitely 6. But you got to remember the water isn't going all the way over to those outside edges. So it really, in reality, it's closer to 5.5.
Yeah.
However, We're gonna round.
I
Okay.
said 5 food, didn't
All right, what about the bottom? This one also got a little sketchy and requires some rounding. What did you guys have for the bottom?
Bottom was. It's kind of hard.
The bottom was 3.
Okay, bottom was
3, they say. 3.5.
3.5.
We're gonna go with 3.5. I'm gonna write 3.5 as a decimal,
3.5.
which is 3.5. And what did we get for height?
1.5.
1.5 inches. All right, so now we've got to do some crazy math. Good thing we reviewed multiplying decimals this morning. 6 times 5 is 6 times 3 plus 3 more. How many decimal spots? 21. So that's these two multiplied together is 21, but then I've still got to multiply times my 1.5. 5 times 1, 5 times 2.
Don't you have to line the decimal?
Space saver. Don't have to line decimals on a multiply.
120.
Okay, 1 and 2. Add it. Guys, there's a lot of people talking. How many decimal points?
Oh, yes, I got it. The one behind the decimal, so 31.5. That's
Okay, so it should be 31.5, 31 and a half cubic inches. So which one of our bowls actually holds more water?
the 31 and the paper bowl.
The paper bowl holds more.
Really?
Now, let's talk about a couple of other things that would be considered research, things we need to know ahead of time. Does plastic float?
Yes.
Yes.
Is it, well,
Will paper float?
Yes. 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 Yes.
When it gets wet and shrivels up.
To an extent. First off, we're lucky because if I just gave you regular paper, it'd get really wet and waterlogged really quickly. But these are the kind of bowls that have that like coating on it, so it's going to be resistant to water. It's going to buy us some time.
Well, if you had a paper bowl, if you like folded it a bunch, it would float.
Right. Paper will float until it gets completely
Wet.
soggy and waterlogged. Okay.
This
tab.
If you just fold the paper.
The thicker it is and the shape of it also helps. So because this is, if I put a flat piece of paper in there, it would not float for very long.
But it float.
But because this is a bowl filled with
Air.
air, it will float for enough time for us to do our experiment. At least I'll put it that way. So here's what we're going to do. Now that we know how much volume they have, let's just test without anything in them other than air. Are they going to float for, let's see, at least 10 seconds, okay? So I'm going to have your bowl ready. Let's start with plastic bowl, okay? Yeah, cameraman Macy. What I'm going to count, class, I'm going to count down, and we're going to make sure our bowl will float. Plastic bowl only.
Plastic
For 10
bowl
seconds.
only.
5, 4, 3, 2, 1. Put your plastic bowl, just set it gently.
1. Sean, don't touch it with your breath.
That doesn't make sense.
Yes, it does. Kane!
I was blowing in it to have a boat race.
Okay.
You're okay, Kane. Shawnee, stop it! It's gross.
It has to be floated
All
down
right.
10 seconds.
It's been
Sean,
way
where did
more
it
than
go?
10 seconds. I lost track. All right, take your bowl out.
Yeah, you
Ball
take that
out.
bowl out.
Okay. Let's try the paper bowl.
Type
Will
okay.
it float for 10 seconds? Get ready. And I will count you down. 5,
Sean!
4, 3, 2, 1.
We're trying to be a good example here. Sean, stop
5,
it!
6,
You're gonna give us COVID, Sean.
8,
Right?
9, 10. Everybody's
And put
paper
your
bowl
mask
still
on.
floating?
Yeah.
Pull it out. Guys, you got to follow the directions on the time. The time matters. Why does the time matter so much?
Because everything has to
That
be
we're
the
all
same.
doing that? Fiona,
I totally followed all the rules.
It's a controlled variable.
the time in water is a controlled variable. I want it to be the same for all of us each time. Now, I am going to, now we're going to do something
Flip the bowl over.
because I know that they're floating, but I want to know how much weight will make them sink.
I have like another version of
We're supposed to be watching the experiment.
What?
We're supposed to be watching the experiment.
All right, there all class.
Yes.
I am putting a pile of pennies on your table.
Sean, don't touch them.
Hello? Do not do anything with them yet.
Okay, so don't touch them.
You guys are gonna
1, 2, 3, 4, 5, 6, 7, 8, 9.
Does the date matter for this? Some of you are checking the dates. Calm down, little chemists. Calm down, my little alchemists. Dates don't matter on this one. What matters is the weight. All right, I need all the talking off, and I need eyes on me. And I don't know why anyone would be playing with Play-Doh right now.
Yeah, who even has Play-Doh?
Okay, guys, 5, 4, 3, 2, 1. Let's be ready to go. All right. So now, because all of us have the same goal, stop and listen. Sit. You aren't touching. Sit on your hands.
Wait, what?
If he sits on his hands, then he is not touching.
Oh.
Everyone, sit on your hands. No. All right, guys, listen. Because we all have the same bowl, because we all have a similar bucket, except for you guys, but it shouldn't matter. It actually does matter because your water pressure is going to be different than everybody else's.
Miss
It's okay.
We can see what
It's
works
fine.
better.
It's fine.
We can see.
All right. I want you to add
I'll do this
2 pennies into your plastic bowl very gently and see if it lasts for the 10 seconds.
There.
All right, go ahead, put it in. 1, 2, 3, 4, 5.
I win the boat race.
7, 8,
9.
10. Is it still floating?
No sinkage, you guys.
All right. Whoa, guys. Did it even kind of sink? Let's add 3 or 4 pennies in there. Count how many pennies you got in there. 3 or 4 more.
3.
So yeah,
Put 4.
go ahead. Let's put 7 pennies in there and see what happens. 7 total pennies in your bowl.
Okay, so get 5. So you only need 5.
7.
Get 7.
All right, and let's get ready to float. On your mark. Are we ready?
Can't move.
Guys, why is there like how hard? 7 pennies in the bowl. Ready to float? Go.
It's starting to sink. If you
Is
put
it
it,
kind of, don't push it. Is it still floating? But it's lopsided.
look, it's locked.
Oh, Ray said he was trying to spread the pennies out in the bowl.
Oh.
So that the weight was evenly distributed. Interesting. All right. It's still floating. Take it out.
Still float.
Okay, now it's even.
Let's put 15 total pennies
Okay,
in there.
1, 2.
15 total pennies in there. If you need more pennies, raise your hand.
I put 1 in. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many do you have? 11, 12, 13, 14. We need to put.
Okay.
See all those?
Okay,
Okay, can I see this? Gonna make it so much faster.
Nothing happened. 7, it got lopsided. Are we ready with 15 pennies?
Yeah.
Not really.
On your mark, put 15 pennies in there.
3,
3, 2,
2.
1, float.
Oh, my baby!
It went down a little. I think I don't have
Stop. I'm spreading them.
All right, pull it back out.
Add the rest.
Let's put 25 pennies in there total.
Boy, you must be tripping.
Wait, Sean, you're doing it wrong.
Guys, quickly.
Sean, we're supposed to have a total of 15. We aren't supposed to add 15.
Raise your
I
hand if you
will.
need more.
We're 1 short. We have 18, so we need, let's see.
We're like a lot short. I think we have like here. Let me see. Just put those in.
Count them. So we have 25 pennies.
We're supposed to have 30. Yeah, we have 30 something.
How many you need?
24. These are 24, 25, 26, 27, 28 pennies.
You only needed 25. All right, we're going 25 pennies.
Guys,
I
that means when you
one.
added 15 extra pennies, that was overdue.
I dropped one.
All right,
Make
let's
it
get ready to
15
float.
and all.
5, 4,
Stop,
3,
Sean.
2, 1, float.
I was
Oh,
trying to even it out, but you moved it.
oh, it's
Oh, some of y'all's bowls are sinking more than others. Macy, you're pointing it at the table.
Trying to look at the one.
Let's do this.
There.
There. But Macy, honey, whoever, it's about to come off the table over here. So, all right. So it's sinking a little. All right.
Like 1 penny's going to change the
Here
difference.
comes something
That's
where
okay.
some.
It
Oh, class.
Oh, yes.
I don't have any more pennies to dole out that much more pennies. So here's what I'm gonna do.
We're going to add the rest.
Did you have 25 turns? Take your bowls out. I need a 0 so I can talk without having to talk on top of y'all. Y'all have 25 pennies
My
there?
eraser fell.
How did you?
Everybody look at the screen. Now you have 50 pennies. All right, you guys.
Yeah.
50 pennies. Put them in.
Hey, wait, watch, son.
Carefully. Stop. All right, let go. All right. 50 pennies. It's about how far? It's about halfway, maybe.
Right there. Right
it's
here.
more than halfway.
You seeing this guy?
It's like 2/3.
Where's your face?
Half sunk. All right, hang on, guys. How many pennies you got?
25.
All right,
We're gonna get 75
Let me take
pennies.
here goes 75 pennies.
We're the lucky ones. Oh, it's on.
Wow, guys, can you wiggle the table?
Oh.
You guys sit down on your butt. Sit.
Look, if
Table
you-
has to stay still. All right,
We have 25.
at this point,
It's like at the
I am
bottom.
projecting it on the screen. Goodbye. Stop touching. Put it in the bowl. Let go. Bye. Sit down.
It's like at the bottom.
All right, here we go.
What if you pour them in while they're in the water?
That's what I'm going to do. At this point, I'm going to start adding them one at a time. That's 75, 76, 77, 78, 79,
There's a little
80,
air bubble under it.
Oh man.
81, 82,
Oh, the water's
83.
going more.
You are, step away. What was that, 83?
Each penny is making you
84.
go farther.
85. We're getting close. 86. This edge is about under.
Put them on the
87, 88,
It's at the touch.
89, 90, 91, 92,
Other side.
Stop.
Put them on left.
93, 94, 95, 96, 97,
Oh.
98,
Oh my God.
99, 100.
100.
Woo! 101. Any more?
Wait.
100.
Two more.
Back up.
There's 103 right there.
102, 103,
Here's another 25.
4, 5,
Stop
6,
putting on the same
7,
It touched.
falling.
It touched.
Wait,
Wait, no.
under.
A little more.
8, 9,
An air bubble's touching.
10.
Stop moving the table.
Guys, stop.
It's
10. There we go.
100.
110.
Oh, it's going down.
It's going down.
All right. Well, you bumped it.
No, I think that was
100.
No, it was
Whoever.
not.
110.
Jason shook it.
All right. Hang on. Now, plastic bowl sunk at 110
Pennies. Wow, that's crazy.
All right.
We have $1.10.
But here's the deal. We're going to need to do some more research.
We have $1.10.
We need to know how much a penny weighs.
And also some pennies.
All right, hang on.
That's $1.10.
We're gonna, DJ, I understand that a dirty penny is gonna weigh more than a brand new clean penny, and that older pennies that are made out of something different, but we're gonna generalize the weight of a penny to get us close.
That's not what I'm saying. I'm saying just in general when they're made out of it.
Is he accidentally
Okay. And now these pennies weigh more because they're wet.
Yeah.
Yeah.
Okay, but anyway, it is what it is. All right, count them into piles of 20.
Give me some.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
Sean!
16, 17, 18, 19, 20.
All right.
Okay, 20. Wait, let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16,
All
17,
right, guys,
18,
we don't
19,
have a
20.
lot of time to finish up our paper bowl.
I got 20 right here.
What if we put more than one paper bowl on top of it?
17.
We have one.
17.
Yeah, we only have one pile of 20.
We have one pile.
Yeah, we only have one pile of 20.
17.
Where's 20? That's
Oh my poor guys. Guess what?
We only have one, Miss Dad, we only have one pile of 20.
No, we have like 25 cents.
That's shiny.
We only have 25
Where's your gum at?
We only have one pile of 20.
That's fine. Does everybody have 20 pennies? You guys have 20?
We have 30 cents.
Okay. That's fine. All right, guys. Take your 20 pennies and put them in the paper bowl.
Oh, okay.
I got easier way.
20 pennies in the paper bowl.
Push it in.
Now even
Oh, God.
That's
I'm
good.
gonna try to get them all flat, maybe.
You guys are doing that.
I'm gonna try to get them like all flat.
Yep.
If I can get them.
Are you guys know what she's doing?
Let's see how many pennies
Man,
it takes
you
to
look
sink
like
a
my
paper
diamond.
bowl.
Okay, that's good. Sean.
Miss Bab, you think I can even it out enough? Oh, wait.
Stop, look.
All right.
There we go.
20 pennies in your paper bowl. Let's get ready to float.
And 5, 4, 3, 2,
3, 2, 1,
One.
float.
Artist really eating
Is it floating?
It's floating perfectly.
All right.
Dude, it's not even under. Well, it's about this much under. That much. It's that much
All
under.
right. Hang on, I'm gonna add.
3.
Okay. Again, I can't do much more than add to this one that's on the screen for everybody.
Yeah.
So here we go. That was 20.
Even it.
Here is 40.
Oh.
Guys, go back to your desk and watch on the screen.
Yeah,
Too many people crowding around. It is going to sink.
See if it's sinking. Yeah.
Well, Miss Dad, it's not level.
Honey, it doesn't matter.
It's always sink, isn't it?
I did it exactly.
It's like trying to raise back up.
That's as good as the best as I can get the camera going,
Do you
guys.
want more pennies? Do you want more pennies?
All right, that's 40 pennies. If you don't sit down, we're gonna have a problem, Paul. You live in the office. All right. 40,
Dude, I don't know.
2, 44, 45,
It's almost there.
50,
We had it perfectly level,
3,
too.
56,
I thought this was going to drop.
79. There's 60.
Dude, it's as sunken as the other penny.
Enough.
As the other one.
61, 62, 63, 64, 65, 66, 67,
Almost level, almost.
68, 69, 70. How many pennies do you have? Plus, can somebody shut the door? 70. Why is there so much talking? I will test your theory in a minute. Zip.
I have another thing.
No.
I want my door shut and I want my students paying attention with their mouths
Shut.
zip unless they have their hand raised to ask a question.
You should have said shut it.
71, 72, 73, 74, 75, 76, 77, 78. Let me ask this. 80. Well, I've got an even number in there. Should this one require more or less pennies to sink? Raise your hand.
More. Less, actually, less.
It's 4 cubic inches.
Zeke, more pennies, why?
It has more volume.
It has more volume, so Zeke says it should take more pennies. DJ, agree or disagree?
Disagree.
Same here.
Disagree because?
I think it's made out of paper and well, this one is a paper bowl. Well, I'm not saying because it's gonna break the ceiling eventually.
DJ says it'll be less because it's made of paper and because then it holds a different amount of air, traps a different amount of air in it. That's 90 pennies right now. Who has more?
Yeah, Miss Deb. At 90s with that one, it didn't go that.
Okay, at 90 pennies on our other one, it was already like about to sink.
Yeah, it was
So here we go.
Sure.
91, 92, 93,
But I
94.
think when you keep on putting this corner in the water, it's going to go in it. Okay, so sit down now. Look, it's touching.
Officially 100.
That side's touching. Miss Dab.
What's that? How much is that, Miss Dab?
110 right there.
We're at 110, guys.
Guys, we're at 110
So this
right
one's at the
now.
beginning. And it's halfway.
11, 12.
That one.
Oh.
It's going to go over. The water's going to go overboard. That side's already
Down
touching.
and watch the screen. Right here on the edge, it's looking a little 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Oh, this one's about to go too. 23, 24,
On that side.
25, 26.
Oh, 120. 126.
27, 28, 29, 30, 31,
Oh my God.
32, 33,
Oh, you're about
Zeke, go sit down. He's about to go.
goodbye,
Goodbye.
34, 35,
It's like touching. It's like, oh crap. It's right there.
36,
Language.
stop, 37, 38, 39, 40. I'm going to run out
It's
of pennies.
unsinkable.
41, 42, 43. I'm going to run out of pennies. 44, 45, 46. There we go. 146.
There's some pennies.
Bring it down. Bring it down.
Holy crap,
All right.
it went under.
Have a seat. Have a seat.
It went under, and it's under the water. Please.
146 pennies.
He's like, I'm quiet.
Paper song. Okay.
Under the water.
It's bad. Okay, so we know. So I know it floats like this now. So it floats like that. But what if you? Okay, so if you like drop it from high.
Hang on. Zeke, let me summarize this because we're almost out of time. Okay. All right, guys. So, turns out that buoyancy is directly related to the volume that it holds. Yes, what it's made of does play a factor. Some things are more watertight than others. A paper bowl is not watertight. If I'd have left only 100 pennies in the paper bowl, it would have eventually sunk before a plastic one. If I would have put 100 pennies in plastic and 100 pennies in paper, the paper one would eventually sink because the paper would become waterlogged and it would sink. The plastic one would probably sit there forever because it would take way too long for the plastic to decompose.
More like 100 years.
For a long, the water would evaporate before the plastic would decompose and
That
sink.
plastic bowl would be like.
Okay, so
maybe a historic time.
so what DJ said wasn't wrong, but as long as it was maintaining its watertight ability, which it was, then the buoyancy is directly related to the volume. The paper bowl had a volume of 31.5 cubic inches, and it took 146 pennies to sink it. The other one was 24 cubic inches, and it took 110 pennies to sink it. Now, how much does 110 pennies weigh? While you guys were counting pennies a second ago, I looked it up. 1 penny is 2.5 grams. And that is according to the U.S. United States Treasury that makes the pennies. So they win. They're right. So if I were to say 110 pennies times 2.5 grams, this is going to tell me the weight of all of the pennies that sunk the plastic bowl. 5 times 0, 5 times 1, and 5 times 1. Put my space holder. 5 times 0, oh, sorry, 2 times 0, 2 times 1, and 2 times 1, add it. 1 decimal point. So the weight of the pennies that sunk the plastic bowl was 275 grams. So 24 cubic inches was sunk at 275 grams. Okay. How much does 146 pennies weigh? 146 times 2.5, 6 times 5, 30, 23, 5, 6, 7. Space hold. Cool, I'm ignoring him.
Can I play water?
No, you may not play in the water. Those of you that play in the water are just trying to some recess. All right, so 31 and a half cubic inches required. You are not interrupting my lesson anymore.
What is wrong?
What?
3 plus 2 is 5. Yeah, 3 plus 2 is 5.
Oh yeah, it is.
Oh, true story.
Oh my gosh.
Yeah, okay, the rest of it's right.
Oh my gosh, that would have thrown off the entire problem.
I mean, really, 365 and 366, largely different number. Okay, all right, it does matter. It does matter. All right, so 31 and a half cubic inches required 365.0 grams to sink. So now our hypothesis, my hypothesis, we never talked about that crud, was that it would require more weight to sink the bigger bowl.
Yeah.
I think we talked about that in the beginning. So true story. We proved our hypothesis. Now Zeke is dying to test something about if the bowl is upside down. So here we go. All right, all of this that I did on the board is our data. And then I drew a conclusion. If you two don't stop, I will deal with you two at recess. I'm done with you taking over my lessons and interrupting me. Done. Clear? Done. All right. This was my data, all of this math, my chart, how much the pennies weighed. Okay. Technically looking up how much the pennies weighed would have been part of my research up here. What was the independent variable? Independent variable? The weight was constantly changing, so we could figure out what sank it. And what was a dependent variable? DJ.
The weight that actually sank it.
The pennies.
The weight, or
The pennies.
Maybe not the weight, but the number of pennies.
The number of pennies.
Because it depended on how many cubic inches.
Something was dependent on the number of pennies. What was dependent on the number of pennies, Fiona?
The container. Whether the bowl sank or not.
Kane.
The data of the weight was dependent on the amount of the pennies that there were.
It's not exactly what I'm looking for, Greg.
How much weight it took to sink the container?
Okay. When the container sank, the dependent variable is when did the container sink? It was dependent on the amount of weight that we put inside of it. All right. So then my conclusion, I used all this data and I saw that the bigger the container, the more weight it required. So that supported our hypothesis that the bigger the volume, the more weight it requires to sink. Now we've got no time, but Zeke wants to talk to us about if you put the bowl upside down. Why does putting the bowl upside down in the water, why does it still float?
Because the air is.
I'm still teaching.
So the air is trapped in here, and the water is like the floor for it, and it's trapped in there. And what I wanted to do, she pushed it all the way to the bottom to see if it comes back up.
Oh,
So,
It will.
yeah.
It has air in there though.
So it does.
Yes. So here's the deal.
But
Yeah.
it's still like farther down.
You can still see air.
There's still air trapped inside of it. I don't know if you guys can see, but you can see, at least in person, you can see that there's a little bit of air trapped inside of there. So when they let go of it, guys,
Another thing.
when you let go, it does pop back up. Now, this is a true thing that could save your life if you're ever in a boating accident. If your boat, this is called capsizes, turns upside down, get up underneath it because there almost always is air trapped there. So you won't drown because you can put your head up in that open space that's underneath there.
higher too, it's like up to here.
Now,
Miss Bab,
I
actually
can
watched a
make
video
this
on
sink really easily if I put it in sideways and fill it with water. Now it'll stay down a little bit. Actually, it came up a little because plastic has air in it. Teensy
But Miss
amounts.
Bab, I actually
it's
showed Zeke that because I watched this solve these riddles if you want
But
to
yeah,
survive.
right now it's
And,
got air in it, and if I push it down, I can hold it there, but I'm having to apply pressure downward. The gravity itself
Under there.
is not as strong right now as the water pressure, so it pops right back
Wait,
up
I have an idea.
because there's
Wait,
still
wait.
too much air in there.
We can see how much weight it takes to keep it down there. At the
We
penny.
could measure now. If I had something to sit on top of this,
Quarters.
we could do a different experiment, how much weight it requires to force it down. But I would, again, I don't have anything to like hook onto here to measure how much weight. And it would also be difficult to keep it balanced. Well, that could be an experiment we would do. We don't have time today. We are going to head back to recess. Hopefully that was fun and enjoyable.
If you
Okay. And we learned a little bit.
Yeah, the paper's decomposing. It's like.
All right. I would like someone at each table to dump the water. I need the big buckets left back there. The plastic bowls, we'll stack them on this counter. The rulers on the back table. And the pennies, we need to lay them on a paper towel to dry. All right, Lucas and Cam, you're good to go. We'll see you at 12:35 for rating. Yes, Cam. You can skip the work.